Sir, Balaji sir, good evening.
Sir, good evening, sir. Hello, sir. Good evening, sir.
Yes, sir. Sir, your voice is very low.
Now, sir.
Yes, sir. Now it is clear, sir. Sir, said that he may join me another 5 minutes, sir.
Okay, sir.
We will start, sir. Thank you, sir. Thank you.
Thanks.
Sir, requesting all to please go on mute, sir. Gurunath, sir. Thank you. Sir Ravi, sir, hearty welcome, sir. Good evening, sir.
Yeah, thank you. Yeah,
Sir Ravi, sir, with your permission, shall we start, sir?
yes, yes.
Thank you, sir. Sir, for dear participants, we are having Dr. Ravi, sir. Mamila Ravi Shankar, sir. He is heading the Department of Mechanical Engineering at IIT Tirupati. We are very much honored to have you, sir. And for today's session moderator, I request our faculty member, Dr. Balaji Ganesh, sir, to continue the session. Sir, now it's over to
Okay, sir.
Balaji Ganesh, sir. Please, sir.
Sir, good evening to everyone present here, sir. Welcome to ATAL Online 6-day Faculty Development Program on Robotics for Industry 4.0, enabling smart manufacturing on day 5. We are pleased to welcome our distinguished speaker, Dr. M. Ravishankar, sir, who is currently serving as Professor and Head of the Department of Mechanical Engineering at IIT Tirupati. He did his BTech from Sri Venkateswara University Tirupati and MTech as well as PhD from IIT Kanpur. He has contributed extensively to research through over 120 repetitive journal publications, 150 plus international conference papers, 16 book chapters, and 6 patents to his credit. He has successfully handled major funded projects with a total sanctioned amount around 200 crores. He has completed 14 projects and currently has 7 ongoing projects supported by leading national and international agencies such as DST, SERB, CSIR, DRDO, ISRO, DAE, BARC, as well as collaborative initiatives like Imprint, Indo-German programs, and various industry partners. He guided 10 PhDs, 40 MTech, and many more BTech students, currently guiding 7 MS and 20 PhD students. Sar is also Associate Editor of Journal of Manufacturing Process and ATAL member of IMECI Journal of Micromanufacturing. He is a recipient of prestigious awards such as Institute of Engineers India, Young Engineers Award 2015 in Production Engineering, Indian Society for Advancement in Materials and Process Engineering 2011, and finalist of Indian National Academy of Engineering Young Engineer Award 2014. Sar also recognized as top 2% scientists across the globe, standard and elsewhere, and among top inventive Indian researchers. Sar and his students received numerous best papers, post awards in national and international conferences. Apart from academic awards, Sar also received Institute Blues Outstanding Sports Personality of IIT Kanpur for the year 2009 for his outstanding games and sports achievement. SAR research expert spans advanced materials and manufacturing, ultra precision and micro nanoing machining, I2 manufacturing, and robotics for advanced manufacturing, among several emerging areas. Sir, we are honored to have with us today to speak on robotics for advanced manufacturing. Thank you, sir. Hello, sir.
Thank you, Professor. Can I start?
Yes, sir. Yes, sir.
Yes.
Yes, sir. Yes, sir.
Yes.
Yeah, thank you, Professor, for the kind introduction and other people. So, my screen is visible.
Yes, sir. Visible, sir. Visible, sir.
So, thank you, one and all, for the valuable introduction as well as inviting me to the Department of Mechanical Engineering for the kind introduction and the other SVEC. So, my screen is visible. In particular, I know many people there who works in the area of manufacturing and mechanical engineering and other things. So I have some of the memories that I visited the institute, being at Tirupati and other things. So today, so this is the area that I am going to work actually. I am not the expert as such. However, some of the areas that we are doing require some robotic based manufacturing processes. So whatever you are going to see is what we have done some work plus what we are getting during our literature survey. Okay, so many things that what we are going to see is what we have done for our purpose. However, we also will tell you where is our expertise. So before I start, what I would like to tell you is that we are looking robots as our assistive systems only, because what we are looking at is developing the technologies. We are not good at developing robots because we are most purely a mechanical engineer. So what we try to do is in a different direction. Just whenever the situation comes, I will definitely will tell you. Okay. So fundamentally, for a mechanical engineer, robot is a system that I am using for my practical application. So similarly, I also look at. Okay. So let me introduce about what I do partially. So our laboratory work in micro machining, sustainable manufacturing, and combination of these things, sustainable micro manufacturing, bio-nanomaterials, additive manufacturing, and smart manufacturing. Under the column of the smart manufacturing, we are going to do some work related to the smart manufacturing. Not only me, our group, Professor Kiran is there, Professor Tyagarajan is there, and other people also. They are also working in similar direction, but we work in a different domain where we use the assistance of robots. That's why I named it as a robotic assisted manufacturing. So first, what we have expertise at IIT Tirupati is, so we have micro machining. So why these systems are so comfortable to manufacture, at the same time why robots are not used in this case? Practically speaking, if you take a lathe process or a milling process, your tool post is very rigid. Even though the vibrations will come, it will take that much, or it will absorb a lot of the loads. That's why whatever the conventional and CNC machineries are designed, because you need to manufacture the similar type of components very often. When you go for a robotic type of applications, when you go for robotic type of applications is when you have the variety most of the time. So variety the most of the time means if you have components, different components on each and every day, then you should go for robots. If you have regularly turning process or a milling process of 1,000 components, or I mean say batch production as well as mass production, whenever you want to go, you have to choose the CNCs or conventional way of doing these jobs, because that is very good for that one. Even robots also good, but up to certain extent. So currently, why I'm saying is, many people are maybe sitting in and around Tirupati. So we have this particular system DT100i, which is a advanced version. What you are seeing here, it has a micro turning, micro milling, micro EDM, micro drilling, micro EDM drilling, micro wire EDM, micro laser is there, and simultaneously EDM, ECM is there, and so on. All purpose machine it is. So the same thing, instead of using a robot, we have a tool post, that too very, very minute. And we also have another advantage of machining titanium and other materials with high speeds. For example, 60,000 RPM and other things. That also attachment is there. Now you can see here, we have whatever the micro sizes that you can manufacture here using micro turning. Once you manufacture this, you can use this, whatever the copper tool workpiece here in micro turning process. This workpiece will turn as a tool in the micro EDM process. Then it will develop a micro hole. You can see here, this much distance is 5 microns. That means that almost all this is 6.5 microns. 6.5 microns is almost, say your human hair is 100 microns. Okay. So like 1 is to 15 times less than that. So you human hair, if at all you want to use for very good type of filament, say filters and other things, you can manufacture this one. So we can also do a lot of complex features like surgical pins. At the same time, you can also make array of pins. So for making drug eluting applications or painless drug delivery to the point care technologies and other things, you can use this one. At the same time, you can also use micro gears and complex features also. So this is all what you can use for your applications. As I said, you can see here the pockets you can make out of this one. So this is the micro milling operation. You can see very, very sharp surfaces, and these sharp surfaces, when you are looking at, in case of the SEM, the scanning electron microscopy and other applications, you can see. So what is the applications of this one? What is the applications of this one is, you can have a drug. This you can use as a mold to make the drug, and these pins, the size of the pins will be very, very less. I mean, say the pore size which is there on your skin is 20 microns, and these sharp edges will be less than 20 microns. If it is less than 20 microns, you can say it is minimally invasive or approximately pseudo-invasive. So that means to say that you can release the drug without much pain or without pain also, because the pore size on your skin is 20 microns, and if you are making the pins of 10 microns or less than 10 microns, that means that you may directly release the drug from the skin at minimally pain or without pain also, as per the time duration is concerned. Sustainable additive manufacturing. So normally we have a big project with Germany. So recently we have completed. This is what the basic problem of 3D printers. So what is the 3D printer's basic problem is, whenever I want to make H13 tool steel, H13 tool steel require the bed temperature in any commercial additive manufacturing powder bed fusion technology is required is 500 degrees. So for example, if you take any type of 3D printers which are commercially available, 5 crores, 10 crores, yeah, anything that is available in the commercial spectrum, so it will have 200 degrees of bed heating. However, here you require 500 degrees. That's why if you don't use preheating of the bed to the 500 degrees, your component will fail like this. That's why we developed H13 modified crucible. I'm saying that we have this one modified H13 that you can do in the commercial machine under 200 degrees itself. Okay. So now with that, that is one thing. And the second thing is we also do the post processing. External surfaces and this is internal surface. This is our biggest portfolio in this direction. So what I want to say is, as such, additive manufacturing commercial machines are there. So whenever you go to anything, when you say that I am working in additive manufacturing, so what you really working is most important. Because already I have a machine which worth about 5 crores, and I say that I work in additive manufacturing, already the machine is doing. So what is your contribution? So your contribution should be either before a 3D printer handles or post 3D printing handles. So this in this way, you should decide your work. And as I said, at the same time, these are the flat samples that one external surfaces to be polished, and these have different types of channels, circular channels, square channels, and other things. This is a bed that you can remove and you can do deballing, roughness removal, waviness, lustrous nature, many things that you can do on this one. So how do we do is we convert the conventional, I would say 3D printed component into a practically usable form. That is what our portfolio is all about, that one can understand how the surface is converted into the surface. Even though I have a 5 crores machine, this is what I am going to get. And this is not going to use in a practical condition until unless if you convert into a post processing. That is what is the biggest challenge that the current world is having. And this is for internal applications. So external applications you can do at any time. But when you come to internal, this is a 3D printed solid model. And this is a channel. How do you polish this channel? This is a very big challenge because this is a non-linear. That's why you cannot use solid cutting tools. We develop semi-solid cutting tools. Okay. What you are seeing on the right side extremely, this is the higher viscous medium and this is the lower viscous medium that you can see there is a radius and other things are available. And what I am saying is inside the channel, this type of finishing is required. So if you see here, we have a system that can be used for finishing these particular materials. You can see here, this is bought indigenously. Now, why and how this is related to the robotic finishing? See, robot is a assistive system for me. So this system, if I have this technology, it will help me to use this technology. Okay, how that and other things. This is what, as I said, the work is started in 1996, and we developed the commercial machine of a smart machine. Here we can integrate this one for the part loading and unloading with respect to the robots. That is what some of the people are using. So this is how our machine look like. So if at all I want to load and unload using robot, then I need to program the robot and you have to do it here. Okay. So now I am coming to robotic assisted manufacturing process. So robotic assisted manufacturing process you can use in machining, because I am concentrating on the area where we are planning to work. So we are planning to work in the area of machining, that is predominantly like milling, drilling and other things, which is more required. Another one is where we want to use is polishing basically. Okay, so another area that we are looking is polishing and finishing. These are the two areas. If you see here, we are not very good at cooperative robots. You might have already gone through some of the robots, which we are not interested. You can see robotic milling system, large milling systems are there, and there are other farming systems, and these are other things. Okay, where we invest our things is here. So if I want to manufacture the implant, okay, the casting of the implant can be done, or a 3D printing of an implant can be done as per the required. Now, here, if you see, you just consider the left side too, okay, where the knee implant, you can see here, knee implant is held and hip implant is held, okay. So, or you can consider both at the bottom side, okay. So, what is the difference that you are observing? You observe the both bottom pictures only. I'm just saying where my cursor is there. So, what is your observation? Clear observation is, in one case there is very high amount of spark is there, where it is a belt grinding process. Here finishing is done in two segments. Once I made a 3D printed component, I am making this particular component to be machined. So to make you more precise, one, you are checking or you are seeing spark enormously. Another side, you don't have a spark, but both are robotic based manufacturing process or robotic assisted manufacturing process. So what is the difference? What is the difference is, in one case, it is doing a machining process. That means that my criteria for this particular application is machining. My criteria is, in a machining, material removal. In the case one, that is the left side, even though I am using the knee implant where the spark is coming, my interaction forces are very high. That's why you are seeing lot of spark. Okay. So in the second case on the right side, same knee implant is handled by a buffing wheel or a smooth wheel where there is no spark. Why there is no spark? Fundamentally, the interaction forces are very less. That means we are working in the two segments, one for robotic based machining process, another one what we are using is robotic based finishing process or polishing process. The disclaimer that I would like to tell you is, either way you can call. It can be robotic polishing, or you can also say robotic finishing process also. Okay. So hope you understood. Based on this, I am moving ahead. So what I am moving ahead is, the summary is the picture bottom left where kuka.com is there, that is using for machining application. That's why the interaction forces are very high. On other side, cloth belt is there where you are not at all seeing anything. So case one, kuka.com, you are doing a machining process. That means your material removal is a criteria. How much material that I am reviewing to give its a shape is your criteria. In the second case, how much material I am removing is not a criteria. How much better surface finish I am giving is a criteria. That's why we are, you can see the smoothness and shininess and other things. So now the first and foremost is simplest process to start is milling process. Okay, so you can see here, historically before 1500, normally working is done by manual, purely manual, where people will be pulling and pushing and other things. Early 80s, you have gears and pulleys, bevel gates and worm gears and other things. And in 1950s, semi-automatic it plays into picture there. You have some semi-automatic inside, and at the same time you have small NCs and CNCs are there. Now in 1970s, you got semiconductor based CNCs, which are chip based CNCs, which people are using. And now people are slowly moving towards robotic based. At the same time, in the area of machining and finishing, people are not that much interested in robotics, subjected to if the requirement is mass production or batch production. If it is a customized production, yes, people will move here, because for every component your programming will be different. So that means that your profit levels will be very, very less if you are doing regularly the same job. Okay, so the profit level will be very less because your operator is mainly occupied by the programming for the given targets or given the components, complex components every time. So for example, if I am getting 1 lakh components to manufacture, so do I use CNC or do I use robot? So normally, preferably you just put a CNC for that one. So once you program loaded, automatically everything will be done. So in that circumstances, you may not use the robotic because it is good for the customization. Second, if your forces are very high, what is the inference from here? From the inference from here is it will work for low load applications. It may not work for very high load applications. Okay. So if you have a low load applications like 50 newtons, 20 newtons, or so 100 newtons also, it may go. But if you are going beyond certain level for hard machining or something, your end effector may not be in a position to accept that much loads. Okay. So now if you see the field of application, normally you can apply for complex surface manufacturing, and you can also apply for large components. Yes, large component, one component or two component or five components, not for millions of components or something. Okay. So that's how, if you see here, so what this robotic softwares and other things will we do? So normally whenever you do, you can also simulate at the first how my tool moves and other things without keeping the workpiece, and you can simulate and you can check. Point number one. Point number two, you can use in situ also. You can keep that one without touching. You can also give certain uh, variation, I mean, say a certain offset that you can give, and you can also do it. So now you can see here. So typical examples of CNC machining tools that you can do the machining process. At the same time, you can also use mobile robotic units. Mobile robotic units, the function of the mobile robotic units is you can move these robots to the large workpieces. So when this is possible is if your component cannot be moved. Simple example is your aircraft manufacturing. For example, I want to manufacture the aircraft structure. So in that circumstances, the assembly and other things, you cannot move that one to the machinery. So what you do is you do the reverse way. What you do, you carry or you just move your robots to the site. That is called mobile robots. So your mobile robots can move to that applications and you can do. Now you can see here wherever the CNCs and other things, as the distribution of global installation of industrial robots, as it increases, now it is stabilizing partially also in some countries, and some countries it is slowly growing and other things. Okay, India is one place where we need to grow a lot in terms of robotics. For example, if you might be seeing regularly, so nowadays people also employing the robots as their soldiers and other things. So we also need to do work to make India Atmanirbhar Bharat and other things. So now the second phase. In this phase, what you require is you have lot of forces. So second phase, as I said, we use for polishing applications. Okay, so polishing applications, as I said, being a mechanical engineer, there are two things. You can be a robotic engineer, either you can be a purely a conventional manufacturing guy who do a lot of consumable study. That is what we do at our laboratory. So you can see here anything, the polishing tools are there. We develop polishing tools. Whatever the tools that goes in the polishing application, we develop. And we procure the robots. We procure the robots to handle our complex surfaces. Okay. So for example, if you see here, this is a robot which we can procure, or so you can use for magnetorheological finishing applications. You can use for rigid conformable cooling up tool polishing applications, other grinding applications, small tool polishing applications, bonnet polishing applications, and so on. Okay, so what we use at IIT Tirupati is we are planning to get the robot for our lab because we have some other robots in some other lab. So for rigid conformable tool polishing applications, other grinding applications, and small tool polishing applications, and similar to the bonnet polishing applications also we are going to use. So this is what the portfolio is all about. So what is the learning point from here? What is the learning point is here is nobody is a can do all the things. If a car manufacturers may be the engine and other critical parts. They may not manufacture the seats, they may not manufacture the tires and other things. So that other things they will procure. Similarly, what we try to do here is that we procure the robot. In fact, it is a critical component, definitely. We don't have much electronics background and other things. We can do the same thing in collaboration with electronics and computers and other mechanical people. We try to develop these tools basically. So other tools, rigid conformable tools, small tool polishing, bonnet polishing, which we are looking at, MRF, and other things. We want to develop these technologies which can integrate with respect to the robot. Okay. So now if you see here, MR fluid polishing system and other things. At the same time, you can also see here integrated robot measuring system and other things. So I have one project with the Fraunhofer ILT, Fraunhofer Institute for Laser Technology, which is in Aachen. Similarly, there are many Fraunhofer institutes in Germany. So some of the people will use these things for finishing applications. Now, if you see this particular video, if you see here, there are two things that you can note. Okay, so what you can note is this is a KUKA robot. Okay, robot has multiple degrees of freedom. At the same time, it is synchronized with the plate. I mean, say basement also. So what we try to do is we try to procure this one robot, and our experience is developing this tool. Whatever you are seeing yellow one, that is what your expertise. That you can see here. So whatever the system that is removing and putting, that is what is we are trying to develop. So robot is not the thing that we are trying. That's why I named it as robotic assisted manufacturing. So we are taking the assistance from the robot, but our expertise is making the tools.
Which is the software using, sir? Robotic, robo analyzer on the screen.
Okay. So you are asking me question?
Yes, sir. Which is the software, sir? Robotic or robo analyzer, which is seen on the screen.
I don't.
Simultaneous simulation.
I have taken from the internet, so I don't have any knowledge on this one. So my expertise, I'm just telling you the clearly that we develop the tools, semi-solid tools. Whatever the tools that you are seeing is not the tools that we develop. We develop advanced tools. So what I'm just showing you is regarding the software and other thing. I don't have any robot with me for your information. So just I am showing you is we develop some of the advanced cutting tools for these applications. Okay, so software and other things I also don't work. So I have just taken for the reference purpose only here. But this is what we are going to invest our next phase of budgets for robotic finishing and other applications. Okay, so robotic cutting, robotic finishing of the glass and other cases. So I'm sorry that I don't have answer for you definitely, because my expertise is assistance only. You can see here, we at IIT Tirupati in other laboratory, not in my laboratory, we have robotic assisted manufacturing with respect to WAM, wire arc additive manufacturing. So if you have any queries, I can ask my colleague to answer later. So if you have anything, you just write to us. We will be definitely helping you. However, if you see Cranfield University, they have a rail system. If you see this rail system, robot is attached on a rail system for manufacturing of the largest components. And preferably, WAM process is very good if you want to go with respect to large components. Okay, so large components manufacturing, you can use a robot for that application. You can use, in this case, two types of technologies are there. One is DED, direct energy deposition. Another one is wire arc additive manufacturing. So indirectly, what I mean to say is that in wire arc also, in wire-based 3D printing also, you can use laser definitely. Laser is there, arc is there. Another one is DED system, direct energy deposition system, where you can feed the powder and along with the lasers and other things. Okay, so these are the components which are developed by Cranfield University, not by me, for large components actually. So whenever you want to manufacture large components, you can see here. So this is particular system is robotic system. At the same time, similar system you can also get in Meltio basically. So Meltio is another company where you can get this particular system for 1.5 crores or something. Okay, so that particular system is there where you can directly get it. At the same time, you can also have multiple lasers and other things. You can see in the manufacturing production is money. I mean, time is money, so you can do a lot of robots that you can manufacture simultaneously by giving the programming and other things. Okay. Now you can see here, robotics can be used for assembly, which is the main purpose. For example, if you see in automatic assembly lines and other things, people will use for assembly purposes and other purposes. However, we are planning to use these particular things for cold spray technologies and hot spray technologies and other things. So what do you mean by cold spray and hot spray technologies? Okay, as I said, it is an assisted process where I have preheated powder will be there. That one we are going to send through HVOF or HVAF. So high velocity oxyfuel based powders that you can see here, and you can do robotic cleaning also. That is what we are looking at. This also can be used in casting applications, definitely for removal of the cores, or if you want to cut the sections in casting. At the same time, recently, if you people are gone, if you can go to Indo MIM, which is there in Kanjalmandi. So they have some robotic system for investment casting applications. We don't have permission to use, so that's a different story. But if you find some time, you can go and you can use. So this is one of the area that we are planning to use, or we are planning to work, because our area of expertise mostly is into polymers. So we try to develop artificial skin, and you can see here the artificial flexible skins and other things. So what we want to do here is that some of the tactile sensors and other sensors and soft grippers. So one of our faculty, Professor Tyagarajan works in the area of soft tactile gripping. Actually, for example, if I want to hold a glass bottle or glass anything, what do? You need to have to hold it very, very softly, but gripping should be proper. In that circumstances, how do you design the polymer? What type of polymer? What type of pneumatics you use? And other things that you can see here at the bottom. So these type of things are the things that our department is working. Anyway, I will tell at this later the stage. So yeah, these are all small videos which are not belongs to me definitely. These are using for assembly lines and other applications. And you can also see here. Okay, so this is you have already seen here. So another thing that we are looking at as a biomanufacturing person is that how do you make lasers and other things, very fine cuttings using the robotics. The same robot that we can get can be used for cutting applications and other things. You can see here. This is for bone cutting applications. Currently, we have lasers, But only thing is that we want to use the lasers. So what we would like to tell you is that we have the lasers, nano lasers and other things. However, we don't have robots which are programmed. But I always says we have, except robot, other things are there. So for me, I'm just telling, robot is like an English medium. I am a Telugu medium person. Once upon a time, I used to study in Samantara Rekalu and other things. Now I am studying like parallel lines and other things. So it is a medium, but my knowledge is where I am developing the tools. And I am using these tools for implementing the technology that I adopted so that I can sell into the market. So that is what we would like to showcase here. Yeah. So here you can see here the grips. So at IIT Tirupati, we developed the soft grips so that it semi like silicone and other applications. Now this is one area where Professor Kiran and us group works. This is what we come to, what we try to do at IIT Tirupati. So again, you don't ask me what is the software that you are using or something. I am not good at the software and other things. So because you may be better person because you have AI, ML, and all the things. So here we have the twin wire arc additive manufacturing system where we have two robots which can build some of the complex surfaces using wire arc basically. As I said, there are two types of heating sources are there. One is laser type of heating source, another one is arc based. So arc based means what you can use in welding and other purposes. So these two are there. So this we in my lab I have laser based, but I do mostly into laser based additive manufacturing and laser based subtractive manufacturing. But here WAM process is predominantly used by this particular WAM or TWAM. So WAM stands for wire arc additive manufacturing, TWAM stands for twin wire arc additive manufacturing or tandem wire arc additive manufacturing also. Okay, so these are the some of the shapes that you can see here. So this is the torch and you can build on top of it. You can do whatever the shapes that you want to do, you can do in this one. However, the future is looking towards hybrid manufacturing. So hybrid manufacturing means what? You do additive manufacturing, at the same time you can also do subtractive manufacturing. I mean to say you do building of certain components slightly oversized, then you do the machining operation like this.
Robots and additive manufacturing go together. Well, Illinois, lifting of large forms in polymer, in metal, are closer to rigidity this robot takes advantage of that rigidity combined with this is not fully bolted down. The cutting that we're showing here, it is light, but in a real production setting, the robot could be cutting aluminum, which is shown here, at twice the speed and a much heavier depth of cut, and could do metals harder than aluminum as well. This is not as accurate as development is big, large metal part could be made through DED and might not need to be sent away for follow-up machining, or at the very least, much less machining would need to be done in another setup downstream. Instead, the DED could be done on a rigid robot like this one, a robot that is also capable of doing CNC milling as part of the same hybrid additive subtractive process.
So what you have seen or what you have
Robots,
witnessed is, okay, what you have witnessed here is that you can 3D print it by using DED process or DMD process. So DED process means direct energy deposition process, and DMD process means direct metal deposition process. So both are synonyms to each other. So there is no much difference in these two. Like some people, they say selective laser sintering, some people they say selective laser melting, they say there it is sintering, here is melting. So slightly they deviate, but bhavana same hai. I mean, say what is the, there is no much difference. So this is one of the area that predominantly India is looking at. So what we want to do here is, when we started negotiating to get this particular machine, the cost of this particular machine starts at more than 5 to 6 crores. So where you can do DED process and where you have extra tolerances, and these tolerances can be machined by, because these are tolerances you are providing. So when you provide these tolerances, you can do the machining to the required shapes basically. Okay. So that is what is all about. So as I said, in IIT Tirupati, again, I reiterate that these are all are solely belongs to our IIT Tirupati. So we do underwater robotics. So for surveillance applications, we have, our department has one of the projects with underwater surveillance system and other things with for precision positioning and technologies and other things. You can see here, we have two faculty who dominatingly work in this area of robotics. One is Professor Yujindra Mittikeri, another one is Professor Tyagarajan. They work on robot development basically. So what you have witnessed is robotic assist. I'm taking assistance. So some people in our department develop the robots. Those people who are interested to develop the robots, what is the software that involved and other things. Some person asked, those people can tell lot of details about that one. But what we try to do at IIT Tirupati, I try to do is robotic assistance manufacturing and other things. At the same time, now we are slowly venturing into one area that is called soft robotics. So soft robotics is altogether new to for us also. But since we have some knowledge on polymers, sensors and other things, we are slowly pitching towards development of artificial skin basically. Okay, so artificial skin for robots. For example, if you see very beautiful humanoid robots, so with a cute face and other things, that is all covered by artificial skin basically. So those artificial skin and other things we wish to develop. Okay, so coming to what we have, you can see here we have finishing. As I said, I have this particular system which I have a lasers, but inside it is not a robot basically. The robot, if I want to have the robot, I can have it. This is micro machining center, this is a finishing center, this is drag finishing center, this is a fine finishing center, and all these equipments are there with us. Those people who want to use, if you want to me to tell the names, This is a rheometer. This is the 3D bioprinter. As I said, if at all I want to print the skin for the robots, for fingers, for face or something, I can print in this orange one. So this looks very, very small machine, but it is very expensive machine, like 30 to 40 lakhs machine. Followed by, you have a 3D surface profilometer, followed by filament makers, ball milling, ceramic 3D printers, and so on, like CNC milling, CNC drill, CNC turning, metal 3D printer, and other things. So why I want to tell you all these things is you are near to us. And if you want to use our facilities, and we are the government organization, and we do at very, very minimal charges if it is there. Sometimes if you have a good relation with respect to our institute, you may also get the free of the cost also. So we have metal 3D printers like VAM, laser powder bed fusion, ceramic, metal, polymer, and other things. Post-processing equipment we have. 3D surface profilometer from Broker we have. Agile Charmelis Viridium we have. Because Viridium is very, very necessary for those people who are working in additive manufacturing. Those people in the institute may be working in additive manufacturing. So you need to dismantle the component from the base plate. So high-speed cameras and IR cameras are there. Micro nano indenter, XRD. XRD we have single crystal is not there for us. Currently we have powder XRD. And we may be getting single crystal XRD soon. CMM, out of roundness tester. PVD, physical vapor deposition techniques. We have DC, pulsating DC we have, and we have RF matron sputtering. So RF matron sputtering, we have two varieties. One is single target system. Another one is we have 4 target system, and tribometer, which we have rotary reciprocating. 3D filaments making. So I have not shown here because lack of the time. Many people people are coming to us for developing the customized filament. For example, people want to publish the papers and people want to do new compositions. So what they come to is, for example, they want to do PLA with some materials, metallic materials, ceramic materials, or glass fiber, carbon fiber, any type of fiber. So they want to fabricate. So we have a better systems. Those people who want to use this filament systems, you are most welcome. Micro machining center, which you have seen already. Laser micro machining center, which you might have gone through. EDM, which we are getting. FESCM with EBSD, this is we got it, and it is yet to be installed. AFM, atomic force microscopy, where I am heading it. So it is going to get on or before March. PPMS, physical property measurement system, and XPS. These are the things. HRTM. So PPMS is one of the costliest equipment, like starting price will be like 11 to 12 crores. So normal top model, you may get 18 crores or something. HRTM is second biggest equipment that you can normally will be like 15 to 16 crores. LIPS we have, laser induced breakdown plasma spectroscopy. DSC, TGA, DTA we have, bioincubator, CREEP, and other. So why I am telling all these things to you is, if intern people are coming, or BTech students are coming, or MTech students are coming, so those people who want to do their job here, we are very generous. We are not going to charge for your real research work. But however, if you can come for larger duration, like 5 months, 6 months, at least 4.5 months or 4 months or something, so you will have a tangible amount of work. For example, you are coming for a BTP project from SVEC, or okay, so the institute will benefit if you publish a conference paper or if you publish a journal paper. Your institute is part of the paper, our institute is also part of the paper. So mutually you can benefit. As you have seen, we have a lot of equipment, definitely. So if you are really interested to pursue your career in the area of research, or if some people are already doing their PhD and they started PhD unable to identify the topics or something, and you want to utilize our facilities through proper channel, it is always welcome. You please welcome and use our facilities, so that what will happen? Our systems also will be regularly used, and we also get revenue generation for the upliftment of our institute. At the same time, regular maintenance of the equipment also will be done, and you will also get an economic price. So you are all welcome. Okay, with and as a associate editor of this particular 6.1 journal, SCA, so I solicit your gracious attempts that you can do for publishing in our journal. So our journal acceptance ratio is very less. It's always in a single digit, basically. So 6 to 9% that you can say. And emphasis will be given purely for the signs that you identify and other things. I request all the people, you should try to publish in our journal papers, and we will be more than happy if you have any queries and other things. Okay. So I am very thankful to all the funding agencies starting at IIT Guwahati. I started in 2012 with 5 lakhs. Then Baba Atomic Research Center, as I said, my first project I received from outside is after 3.5 years. And from Baba Atomic Research Center, about 23 lakhs. DST about 96, which is nearly 1 crore. DRDO about 75. IT about 60 crores. Imprint with IIT Kanpur and ISC Bangalore 3 plus 3, 6 crores. These are all I did at IIT Guwahati. So SCRB special call about 45, BIRAC about 40, SCRB, CRG about 52. And recently I closed IGSTC 2 plus 2. So out of many applications for Indo-German, so only 5 people across India selected, or 5 to 6 people they have selected. So one of them is we at IIT Tirupati. I at IIT Tirupati. So we concluded, and recently we started working in collaboration with ISRO for 3D printing of some of the complex materials. And STI just now started. So we are recruiting. Yesterday you might have seen my advertisement on LinkedIn. So we are recruiting 2 project staff. So in the area of manufacturing or mechanical engineering, some management skills, some skill sets are required. So we have some projects in IKS, TAIR and other things about 56. And we have CARS project about a DRDO 17 plus 42 lakhs now we received. So almost all 60 lakhs we have in this one, and 20 lakhs for power grid. Apart from it, we also have a TH on precision technologies and positioning about 120 crores, which we are trying for micro manufacturing for precision technologies and positioning. And this is one side, and I have a beautiful team. Whatever I am doing is this. So the complete summary that I would like to tell you at this junction of time is, we are going to use, we means my team, are going to use robot assistance only. We are not going to develop the robots, definitely not, because that is not our expertise area. Because if at all I want to develop, I need to have mechanical, electrical, electronics, computer science, lot of things, which that is maybe not possible for me. That's why we develop these polishing tools. Milling tools and other things are there. So we develop novel polishing tools that integrates with respect to the robot, that you can do the finishing operation. With that, I am very thankful to the people who has given the opportunity to showcase what we do and what we try to take the help. Thank you.
Thank you so much, sir. Thank you, sir. Sir, Balaji, sir.
Sir, yes, sir. Yes, sir. Hello, sir.
Sir, dear participants, if you have any doubts, 1 or 2 doubts, sir. Sir, with your permission, Ravi, sir.
Yeah, please.
Thank you, sir. Thank you. Dear participants, if you have any doubts, please.
Sir, in micro machining, the tolerance to which the tools will be manufactured, sir? To what tolerance the tools will be machined?
I'm not getting you rightly, but you mean to say what is the tool size? What is the diameter of the
So,
tool?
means accuracy, sir. To what accuracy the tools have to be machined? Say like 5 microns or less than that, like that.
Accuracy of why you want accuracy of the tool?
No, means using that tool, if you want to drill any hole or machine some feature, in that case,
So you mean to say if I have a 100 microns tool, what will be the tolerance?
yes sir, yes sir, yes.
I also don't know. I never worked in that line. But maybe average diameter should be approximately plus or minus 2-3 microns, 1 or 2 microns. If you go for a macro tools, if you go for a micro tools, it may be less than 1 micron, maybe.
Okay sir, okay.
Fortunately, people are asking what I don't know today.
Sir, we will be sharing your mail ID, sir. If any participants are having any doubts, they will contact you, sir.
Yeah, so that should be fine.
Shall we go for vote of thanks, sir?
Sir, just a minute, sir.
Please, please.
Myself, Dr. V.L. Krishnan. I am a faculty in Dhanekala Institute of Engineering Technology, Vijayawada. So, sir, how we can means what are the conditions, eligibility conditions for a student to pursue internship at your college, like a BTech graduate in a final year program, means final year of his program, or
Okay.
for internship, summer internship?
But see, the thing is that, sir, practically speaking, the student who comes to us, if he comes for effectively 1.5 month or 2 months, by the time he settled down, it will complete. So normally we don't want to take such cases where neither your institute will get benefit out of it if he spends at least 4 to 5 months minimum. Okay, so preferably if they can come for their BTech final year project, you may have 1 semester, or some institutes will have universities. Some universities have 1 year also. So they will come for 8 to 10 months. Some people, there are two varieties of people that we are getting now. One people is like 4 to 5 months. Another set of people is 8 to 9 months. So those people who works for us 8 to 9 months, they are publishing very good along with our students. So since they are also associated with their institute and associated with their faculty, so we have a collaboration with them and we try to combinedly publish the paper. Those people who comes for 4 months or 5 months depend on the sincerity and hard work of the particular student. They may be publishing a small journal, or they may be publishing a conference, or they may not also. Okay, it is subjected to the what type topic that he has taken, what is the many things, because nowadays things are depend on the student's sincerity and how what topic he is want to do and other things, what is his interest and other things. So we try to not charge anything for the research as such, but we request the student to take care of their accommodation and food. And currently we don't have that much accommodation, so normally people stay nearby and they do. So the summary is, we are open for BTech projects who can come at least for 4 to 5 months. We are open for MTech projects. We are open for PhD students who want to come and use and the facilities. That is also fine.
Okay, sir. Okay, thank you,
So
sir.
if any further question, clarification is required, you can ask me.
Yeah, no, I got it. Minimum, it is preferable if 8 to 9 months at association is there for a student.
Yeah, 8 to 9 months, I think normally MTech students will come.
Yeah, they
So,
can
what is how many months you have BTech project duration?
BTech students normally they are sent for 6 months like that. Last semester is made free. Means such type of provision nowadays it is made. All the courses, theory work, everything is wind up in 7 semesters, and
Mhm.
last semester is made free for their project work.
They
So
can come, sir. They are most welcome.
okay, sir. Okay.
Subjected to our area of interest.
Yes,
So
sir. Yes, sir.
normally,
Definitely.
what you one can do is we can have an online interaction
Yes, sir.
so that no the students you being a head of the department or being a faculty who want to send you. See,
Yeah.
I cannot guide in the area where I don't have expertise. If you ask me to make a robot, I say no.
Yeah.
It is
Certainly.
not
Sir.
my area of interest. And
Yes.
that's why I said I do use robot for assisting my work.
Yes, sir.
Okay.
Got it.
So we develop the cutting tools, soft cutting tools, and we try to fix to the robot. So robot we can play. Okay.
Yes.
So we use the robot for our applications as a system like CNC machine I use, robot also I use.
Yes, sir.
So, but
Sir.
the problem with the robot is it cannot hold large forces. That's the only problem because it is a cantilever beam.
Yes,
As
sir.
soon as you put 100 newtons or 200 newtons, stop, it will
Yeah.
jump off. So
Yeah.
tool also will blast, and sometimes manipulator also
Yeah.
there is a chance of damaging. So
Yeah.
that's why
Yeah.
we want to use for low load applications actually, like finishing applications.
Yeah. Yeah. So
So
one
as
more technical question, like you are just now telling during your presentation that you are now getting interested in soft robotics, means like basically creating skin for robots.
yes.
Arti- So like for that, what type of some 3D printing technology you are adopting or what, sir?
No, no. See, 3D printing is a very expensive technology, sir. As of see, many people they say that they are working in 3D printing. I also say I also work in 3D printing, definitely.
Yes,
But
sir.
let me frankly speak, 3D printing is a very costly affair.
Yeah, yeah.
Okay, if I can generate a robotic skin,
Mm.
so I can generate by normal conventional manufacturing process. Only thing where my technology will come into picture then. So where my technology will come into picture is that the composition of that material.
Yeah.
Okay, I want a humanoid robot which looks like a very beautiful girl,
Mm.
a woman, or a man, anybody, handsome man. So I need, for example, if I put like this, it should fit. It's a soft one.
Yes.
Okay, that is what I am looking at actually.
Yes, sir.
If at all I want the fundamentally, what is the thing? I can use the silicones. Now under silicones, you have varieties of hardnesses. Okay, so this is called shore hardness. So you have 20, you have 40, you have 60, you have multiple. I'm telling about the liquids that are available. And I
Okay.
can do the molding basically. So I have a cross linker, I have this one. You see that if you go to the shops, it's a cloth shops, lot of statues will be standing where shirt will be there.
Yes, sir. Dummies. Yeah.
Yeah, so they will have some standard face. You can bring that one, and I can pour my silicone and the cross linker everything, and I can just get the skin out of it.
Okay, sir. Okay. Yeah.
So that is easiest part for me rather than 3D printing the same thing. If just to see that dummy statue, if I want to 3D print how much it is expensive. It is too much expensive. No?
Yes, sir. Yes, sir.
If I want to do by a injection molding or something that is easy for us.
Yes, sir. Yes, sir.
So similarly, we want to adapt, but the point here is what is the composition. So we work that way. We work into advanced materials and for this one, where we use robotics as a assisting things.
Okay, sir. Thank you, sir. Thank you very much, sir.
Okay, I am nice that I am seeing my own face here. So thank you, the people who has given me the opportunity, and hopefully we'll see you soon sometime, sir. Thank you. Can I leave?
Thank you very much, sir. A vote of thanks, sir, as a formality.
Yes, sir. Sir, thank you, sir. On behalf of SCC Tirupati, I extend my sincere gratitude to our respected speaker, Dr. M. Ravishankar, sir, for delivering an insightful and inspiration session on robotics for advanced manufacturing. Sir, your vast research experience, your contributions to national projects, and your vision for advanced manufacturing has given us a deeper understanding of the future of robotics industry. We truly appreciate your time, valuable knowledge, and the clarity with which you present complex concepts. Sir, thank you, sir. Have a wonderful evening, sir.
So clarity I have given that I don't do robot, I do only an assisting robot. Okay.
No issues.
Thank you. Thank you, sir.
Thank you,
Good
sir.
night, sir. Good night, sir. Thank you, sir. Good night.
Yeah,
Good night, sir. Thank you.
very good night. Yeah, still I'm in a HOD office only.
Yes, sir. I'm seeing you in the office only. Right, sir.
Thank you, sir. Thank you, sir.
You can see how dull is my face. So till 5:30, I am there with a lot of meetings.
Okay, sir.
So thank you, Rajesh Garu and other people, and those people who want to connect to us. You can take my number from Rajesh, or otherwise, if you might have noted, last slide my number is there. So, or I'm just putting here, but don't share to the students. That is my, I don't know, chart is not, I cannot.
I will enable, sir. Just now I will enable, sir. Sir, it is enabled, sir. Please, sir.
So those people, we are looking for the good candidates who can work with us. And not only that, if you have any right candidates who can join our team.
Sir, even today also you have posted in your LinkedIn opening.
Yes. So I have posted that one. So those people, we are looking at MTech level and BTech level. So at the same time, don't look at the money or other things, but my wish is you should able to, or we should able to combinedly publish. That's the only issue. Say I want it. Okay. If you send for long time, so good amount of work will come where you will also one of the authors, we are also one of the authors. And it is not about student who is sending the faculty also will be author of that one. So that we work together. Thank you, sir. With this friendly note, thank you all.
So kind of you, sir. So kind of you. Dear participants, we'll start another session by another 5 minutes. You can take break. By 7:30 we can start. Thank you all. Sir, hearty welcome, sir, Dr. Harsha, sir.
Thank you, Rajesh sir. Good evening.
Sir, good evening, sir. Sir, first we will formally introduce you, then you can share your slides, sir.
Yeah.
Sir, Rajesh sir, can I go, sir?
Okay, sir. You please carry on, sir. Yes, sir. Balaji, sir.
Good evening, everyone. It is my great pleasure to introduce today's distinguished speaker, Dr. Harshvardhan sir, Managing Director of On Allies Hindupur. Dr. Harshvardhan sir is an accomplished academician, researcher, and industry leader who has made significant contributions in the field of engineering and industrial applications. He holds his PhD from JN2 Anantapur, and his professional journey reflects a rare blend of innovation, scholarship, and practical industry expertise. He has an impressive research portfolio that includes 3 utility patents and 1 design patent, along with 20 plus research papers published in reputed journals. His global academic presence is the future highlighted by 25 plus international conference presentations. In addition to research, Dr. Harshvardhan sir has authored 5 books, reports, and chapters, and has worked as consultant to various industries, helping them improving process through his technical expertise. He also sought after academic speaker, having delivered 20 plus guest lectures across reputed institutions. Moreover, he has served as a conference chair at both national and international conferences, demonstrating his leadership and recognition in the scholarly community. Today, he joins us to speak on the topic case studies and success stories of industrial robotics. Sir, we are truly honored to have him with us. Sir, I'm handing the session to you, sir.
So thank you, Balaji sir. It's a great introduction.
Thank you, sir.
Sir, kindly switch on your camera also, sir, for recording screenshot purpose.
Sure, sir. Yes, sir. Good evening, all. Welcome to my lecture, Case Studies and Success Stories of Industrial Robotics. So, shall I start, sir?
Yes, sir. Yes,
Yes,
sir.
sir. Yes, sir.
Yeah, thank you. So, thank you, myself, for giving this opportunity, and thank you, SUC College of Engineering, for this wonderful opportunity to meet and explore to discuss about the things about the advances in robotics for industrial applications and its success stories. And let me brief you about so I'm a foundry guy. So currently we are running an industry which is actually an aluminum recycling. So this is a recycling foundry unit. We collect aluminum scrap from various sources. Then we will melt it and we'll cast into the aluminum ingots, and we will again give it to the automotive electrical companies. And inherently they are all again foundries. So as a foundry guy, so when Bahai sir asked me about to discuss about case studies and success stories of industrial robotics. So I thought to explore, I thought to discuss more about the field of foundry where these robotics are nowadays getting explored. And I want to give some insights to the young entrepreneurs and professors about the challenges where the foundry is feeling, and the scope for new entrepreneurs where they can be able to pitch it. So these are the things I want to present in today's lecture. Uh, So here, why robots are used in foundries? As we know that the critical challenge was the foundries are most demanding manufacturing environments in the earth, and you know that most of the metals are came up through the foundries only. Even though we have advancements of like 3D printing and other additive manufacturing, but rather than 90% of the metallic components are getting manufactured through the foundries only. And in the foundries, you know that we are always dealing with the high temperatures and the toxic fumes and the corrosive chemicals. So these are the major issues. And having skilled labor is again a bigger issue for the industry today. So in order to avoid these accidents and to handle things safely and to work repeatedly, so we require robots in the foundries. So these are the major. This is a major critical challenge where which I would like to address today. So you know that robots could be able to give 24 by could be able to work for 24/7 operations, and also they can handle the molten material with very high precision, and they can also work in the safer environment. So when we have a human beings interactions, you know that due to fatigue of the workers, there is a lot of hazards happening in the industries. We can able to avoid all these things with the help of robots. So what are the foundries? What kind of robots are used in the foundries? So we mainly use basically articulated robots, that is multi-axis flexible arms. Since all are much familiar with the robots, so I'm directly jumping into this subject. So rather than explaining about all this, what is multi-axis, what kind of axis, what is degrees of freedom of the robot, so I'm just directly jumping into the topic. That is articulated robots. So that is multi-axis 6+ degrees of freedom robots are generally we use in the industries, and we use self-mounted robots, that is for space-moving compact units for dynamic reach capabilities, and as well as perfect machine training, part loading, unloading works. So for these works we use self-mounted robots, and also we use heavy-duty robots. Why? Because of we need to carry the molten material with the help of a ladle. So which is almost the ladle itself passes some 200 to 250 kgs. So where again we are carrying some 150 to 200 kgs of molten material, almost some 500 kgs of heavy weight we need to operate, and repeatedly it has to work. So for that purpose we use heavy-duty robots, and also a few specific specialized foundry robots for fettling and other operations that I will show in my consecutive lecture. So these kind of robots we normally generally use in the foundries. So, and you know that what are the benefits that we are going to get for this foundry professionals or as technocrats. So the first one is, the first and major advantage was safety. The safety, enhanced work safety. So with the use of robots, the work environment will be very healthy, hygienic, and as well as very safety. So we can avoid all these burns and the strains for the human beings, and also the production performance. With the help of the term OE, you can remember this term, the overall equipment effectiveness. That is, without that we can call as a less overall effective equipment effectiveness means that we can consider as a defectiveless components percentage. So here with this introduction of robotics, the OAE can be increased by 20 to 35% in some cases. I'll show you the case studies where the we prefer the robots in foundries especially. So in order to increase our OE, that is overall equipment effectiveness, and also for superior quality. So with the help of robots, we can able to achieve superior quality, and also we can go for optimization. Since we'll be having the data with us, that is a robotic arm, how many number of times it is moving, how much distance it is moving, what is the volume it is covering. So all this data will be having, the data can be used for optimization with the help of AI. So with this purpose, so these robots are much useful. Yeah. And the challenges and training is why, because in the robotic environment we need to have a extreme environment maintenance. So the robots which are used in these foundry areas should be compatible with high temperature applications, and they should have some protective coatings, and as well as the protective care should be taken in order to avoid the accidents during the site. This is one of the major challenge. Why? Because when we handle it, suppose if you consider the aluminum foundry, we will be operating around 800 degrees centigrade. If you go for the zinc foundries, they will be operating almost from 450 to 500 degrees centigrade. And if you go for some steel foundries will be operating almost 1800 to 2200 to 2400 degrees centigrade. So when we operate with these high temperatures, so the robots which are used at this temperature should have that capability to work at that particular environment. All the robots which are we kept should have that thermal management as well as thermal fatigueness. It should be able to protect them. So this is one of the major thing, and also the workforce upskilling program. So here what happens is we need to train the persons who will operate the robots. So the robots, even though only once we train also, but that robots, the person who will operate should also have sufficient knowledge in that particular task, the operating of the robot. So the future collaborations, if you see that with the help of AI, so we could able to adapt AI in this robotic foundries, so that in the foundries what happens, the robots nowadays, previously all the robots are self-programmed. So that means once we program with that old program only, continuously they are all operating. If you could able to introduce AI, so that they can able to optimize all the robots, they can optimize themselves and they can work more effectively and efficiently and collaborative, so we can able to make more number of robots to work collaboratively, and we can make a predictive maintenance. That is, with the help of IoT sensors and AI technology, we can come to know that when there is a maintenance required for a particular mission or particular robot, that we can able to make a predictive maintenance with the help of this AI technology. So robotics, as we said, robotics are mainly used for safety and smarter foundry applications. So with this human robot synergy, major foundry industries are now becoming healthy and hygienic and comfortable for people to work together. So with this Industry 5.0 complete automation and human ingenuity will create future manufacturing excellence. And where these robots can be fit in this foundry applications, especially these four areas, major areas where this can be fit. The first one is molten metal pouring. As I said, the handling of molten metal was a very, very, very tedious thing in the foundry. The handling of the molten material, that is pouring of the molten material, one of the key area. And the second one is hard cast handling. That is, after pouring the molten material, the material will get solidified, and the cast component, which is at high temperature, handling that particular component is again a second major challenge. And the third one is removing this hot metal casting and package. After cooling continuously, we are loading and unloading all these machinery operations, that is mission training operations, loading, unloading, packaging, these things are there. So these operations are where the robots are much required thing. And finally the quality control, so that is deburring, fitting and grinding. For these operations, these are the four areas where the robots are required in the foundries. The first one is molten metal, handling the molten metal pouring, and second one is after pouring, handling the solid material, casting, and third one is loading and unloading the machinery operations, and fourth one is fitting. So these four areas where we require are robots in the foundries. So I just want to show a small video regarding the automation introduction in the foundries. Just go through it. Sorry, just. You can see one of the foundry which is automated fully. These are all the ingots what we manufacture there. That is sample collected for testing, and that sample will be numbered. So after melting the molten material, the sample will be collected from the molten bath, and it will be tested for its composition. After that, the molten material will be poured into the transfer ladle. With the help of a transfer ladle, the molten material will be carried between the foundries. This is called degassing. In order to avoid all these casting defects, the gas entrapment, so the degassing will take place. These are all the various dyes. Yeah. So pouring of, yeah, as we see in the previous one, so in an industry end-to-end component manufacturing place, so where initially the automation has starts from bringing the raw material, that is ingots, into the foundry furnace. So where we will melt it, from there after melting the testing. So from there the pouring of the melted material. So after pouring, handling the cashier component. After handling the cashier component, then we will undergo for some petting operation. Then the quality checking, and finally packing and dispatching. So these are the stages that you have seen in the previous video. So here coming to the handling, the pouring of the molten material by robots. So why the robotic pouring is required? So what happens when we pour with the manual pouring? So when we pour with the manually, the pouring time is not consistent. The first point. So with the since the pouring, when the pouring time is not consistent, the quality of the casting is not consistent. So there is a major problem which is industry is facing. So with the tier 3 tier 4 companies, that is very small scale industries. So that's the reason actually the castings, when we go with the bigger companies, the casting finishing quality is good because it all having the robotic pouring, that is for uniform pouring applications. So since we have a robotic pouring in larger scale industries, where the casting quality is much better when compared to the small scale industries. Nowadays, even with some advancements in the GDC, that is, we have two-stage pouring. That is, in the first stage, manually we pour into the chamber, and the second stage, the machine completely it will get tilted. So during the tilting time, the molten metal which is be poured in the initial chamber, that is get fed into the second one. So that is happening nowadays with some advancements to sustain the small scale industries. But even though for medium and large scale industries, they are all using this robotic pouring. So this robotic pouring, the challenges are handling of the molten material. That is, the robots which are handling the molten material, the work envelope of the robot should be designed very carefully, that no other machine component or no other robotic arm will come and touch in between. Well, because of we are handling with very high temperatures, when we are working with a higher temperature, more than 1500 degrees centigrade, so it is very typical to work with the temperatures. So for that purpose, actually, so the challenging was handling that particular high temperature one, and designing the work envelope. These two are the major challenges for this particular robotic pouring. So the traditional pouring, as just said, the traditional pouring is having various variability in pour rates, that is timing, pouring timing. So that results in casting defects, material wastage, and costly rework also. So, and here was the safety risks and quality issues and production limits were these challenges were addressed with help of a robotic metal pouring. This is a very good interesting area where you could the professors could able to do task to scholars to work on this particular domain. The precision in action. So what happens when you flawless with the flawless pouring? What is happening is the accuracy will be good, and so that the transformation of molten metal into the precision component will take place with this robotic pouring. So with the robotic pouring, what happens? The revolutionary system, automatic stapling, skimming, and precision pouring in advanced foundries in the worldwide. So major companies that is like General Motors, which is initially, so as you know, the robots first introduced automation was first introduced through General Motors only. Again the General Motor people, so they were again introduced these robots in the pouring. They have achieved a good result in this one. So here we require what are the requirements for this process is that is heat resistant equipment. The industrial robots are equipped with the specialized end effectors so that the thermal shielding and safety handling molten metal at extreme temperatures should take in place, and the robots should deliver the molten metal into molds with microsecond timing control and exact flow rates. And even there should not be small any jets here. So with the small jets also, what happens is molten metal will jump from this ladle, and it will again affect the self body as well as the surrounding environment. So that there should not even small jet also. It has to work very precisely when we are handling with the molten material. And the advanced AI sensors should be used. Suppose if any some real-time obstacles were there, so they are you should not supposed to make a sudden jerk or sudden breakage. It has to go very slowly and smoothly. For that purpose, actually, we need to have some intelligent adaptation here when we using the molten materials, the pouring of molten material, and the complete automation is required. And coming to this molten metal handling, nowadays, previously, what happens, sir? The raw metal might be manufactured somewhere like any zinc ingots or aluminum ingots or copper ingots. Or the steel bars, the steel will be in the form of billets that will be made in the one X unit, and it will be get transported to the casting industry, where the casting industry is having a bigger furnace where it will make the raw material. It will make sure the quality of the raw material, as shown in the previous video, with the help of some spectrometer or some other necessary equipment. So they will make sure the quality of the raw material. After that, they will take it to the transfer ladle, where there they will make all the degassing process. Then it will shift it to the furnace, which is called holding furnace. With the help of from the holding furnace, actually the casting is happening. This is the conventional method. But now the advancement was happening in such a way that all these raw material manufacturing foundries are establishing near to the consumer port, consumer factory. Suppose in an industry area like Hosur or Asri City. So where we will be having n number of casting units are in Ranipet, so Chennai. So we'll be having n number of casting units. There only the raw material manufacturing people are establishing their facility. From there, so they are transferring this raw material in the form of molten material instead of ingots or billets. So they are transferring their molten material into a transferring flask on 200 kg or 300 kg or 500 kg capacity. That transferring flask is having up to 2 tons of capacity. So they will transfer this molten material, they will pour this molten material into that particular transfer ladle. They will seize it. That transfer ladle is preheated and it could be able to withstand the temperatures up to 3 to 5 hours, so that the material is getting transferred from the industry where the molten material is manufactured to the end consumer, that is the die casting people. So the molten material is transferring, the material is transferring in the form of molten. There again, with the help of robots, they are testing the quality of molten material. Then they are lifting this transfer flask and pouring into this particular what we call the holding furnace. Their casting process going on. So with this, the advantage is the casting industry is need not to maintain any inventory. The inventory cost getting reduced. And second thing is the casting industry no need to melt the raw material again, so that the melting or heat loss and pollution will get reduced. So this is the most advancement which is happening in this casting industries. So here again we are having another addressable challenge for the researchers, that is the effective way of transferring the molten material through transfer ladles to hold to withhold the temperatures and most effective way. So this is another challenge that the researchers who are interested in these foundries, they could able to work on this area. And so the key advantage, as I said, key advantage of molten metal pouring was safety. One is the first one is safety, second one is precision, third one is productivity, and fourth one is efficiency. And it is proven that the 75% of the time reduction was happening. That is, manufacturing cycle time was saving. Since there is no human fatigue, if you work with the humans cannot work continuously. They cannot continuously lift the molten material from the furnace, and they cannot pour continuously at the dies. So they require some intermediate gaps. But robots, they won't take any intermediate gaps there. We will get the time reduction, the manufacturing cycle time could be saved, and the safety is enhanced. So you know that the remote we could able to make remote temperature sampling, since when we work with the robots, the human interventions are completely reduced. We can work with we can work very remotely. Automatic quality control we can make, temperature sampling we can take, and you can make predictive maintenances also. So what happens is when we shift from traditional manual pouring to robotic pouring, so here we'll be having zero exposure, zero human exposure to hazards. One of the major advantages we get, and as well as the second advantage is we can work at the controlled environment with precision and consistency. And even one of the industries, few industries who are having completely fully automated, no need of human intervention. They are called as the dark industries, where we can switch off the lights, no need of lighting also. Since because of everything will work with help of sensors, the robots, they could able to work themselves, and finally the product will coming out. There are few industries are emerging in India. These are called the dark industries, where no need of human intervention at all. So even if nowadays we are working with the industries where the human intervention is required, even though we are working with complete the CNC machines or robotics machines. So for the feedback system or some control points, humans are getting involved. But few companies are emerging in India also now. So where the zero human intervention is required. We need to feed the raw material on one side, and finally we can collect the finishing goods on the other side. The complete end-to-end automation is going on. Those industries we are terming it as dark industries. And the future trends, as we said, the electric furnace integration, the cleaner and most precise molten control is required. So the reduced emissions will be able to take place. So the furnace controlling is one of the area where we could be able to work, since to avoid to completely eliminate the human intervention. These are the areas where we could, there is more scope for the researchers to explore more. And second one is AI-driven adaptive pouring system. That is real-time optimization of flow rates based upon the thermal imaging as well as sensor feedback and as well as some real-time obstacles. So where AI could be able to integrate with and we'll be having industry expansion that is a growing adoption across the aerospace, automotive, and heavy machinery manufacturing sectors. And we will be having sustainable gains, that is energy efficient process, reduced material waste, and lower environmental impact. So here the future is automated. The competitive advantage we'll be having. So in this for this robotic pouring. So here you can see a small video about the robotic pouring. This particular thing is called a ladle. So we'll be having a transfer ladle. You can see this. So normally humans, the labor who is working in this particular task, the skilled operator we call as. So that operator has to dip this transfer ladle and he need to pick the molten material precisely, and then he need to pour this one into die. But here with help of complete robotic, so we are processing this one. The robot itself is lifting the molten material and pouring into the gravity die casting machine in the chamber one. Here you can see another small video. So this is robotic arm is lifting the molten material and pouring it into the dice exactly. So here another robotic arm is lifting the solidified ingots in a properly then and keeping for packing. And another area where the major area where it is actually required and the most focusing area is robotic sorting. See, in any industry, major in the recycling industry, since I belongs to recycling industry, then our recycling industry, the major challenge for it is sorting of the material. So we will get a different kind of materials. So as in the scrap, so we need to sort, we need to separate the aluminum, zinc, magnesium, plastic, iron, separate. We need to separate them. Then we need to utilize it for a proper melting. In aluminum also, we will be having n number of grades. So the sorting with help of a human is required. It is a very tedious job. So for that, the robotic sorting was one of the major focusing area where the government of India or globally, the more funding is focusing with this. So sorting, even we will be having Ministry of Mines funding program also for this one, the robotic sorting. So and as well as sorting with help of some robotic with help of some X-ray. X-ray detection, that is if with the help of X-ray, if you could be able to identify the material and then if you could be able to sort it and the real-time sorting, then you could be able to apply for some funding project under Ministry of Mines also. So this is another major area. So here you can see this separating or picking up the material. The different materials, so you can program it for separating in the various stages. You can separate plastic ones, you can separate aluminum. And aluminum itself, if you take, we'll be having a number of grades. If you go with the steel, in the steel also we'll be having a number of grades. We'll be having stainless steel, mild steel. So so we can separate the stainless steel and mild steel. separately. When you go for the industrial waste, so we'll be having, suppose in an industry collectively, if the waste is processed, there will be having all the hand gloves will be there. We'll be having steel particles will be there, steel powder will be there, MS, and we'll be having the aluminum will be there. There you could able to separate. That's also another interesting area where you could able to work really. The automation robotics transforming in this Indian foundries, how they are transforming. I just wanted to bring 2 to 3 examples here. So the Indian foundry industry is a growth powerhouse where it will be a $61 USP, sorry, 61 US dollars, 61 billion US dollars market by 2032. So majority of the industries now are getting automated. So now people who are wanted to get, enter into start their own venture. So they wanted to make a one startup. They can focus in this area, that is converting existing industries into automated industries with the help of some robotics. In this area, the startups are much encouraged. Here also you could be able to focus. And the more demand is there in automotive sectors, especially in the manufacturing hubs, you can focus. Here in India, we'll be having 5 manufacturing hubs. One is Gujarat, another one is Maharashtra, third one is Tamil Nadu, and fourth one is Karnataka, and fifth one is, as you know, we are growing the Andhra Pradesh is also again 5th manufacturing hub. So here also you can focus on converting the existing industries into automated industries or promoting new industries into automated side. So in this robotic area, we'll be having much bigger business scope. The people who newly wanted to enter into the business area, so they can also focus in this line. So what are the challenges are faced by Indian foundries today? So that is the first and major one is skilled labor shortages. You know, as a mechanical guys, we all speak together. So the skilled labor was the availability of skilled labor was much difficulty in the industries now. So the graduates, you know that the mechanical graduates are becoming precious. There will be very less number of people are graduating in the mechanical engineering, and also in the diploma level or in the BTech level. So we'll be having a we are going to face a huge shortage. The industry is going to face a huge shortage with these mechanical graduates. And even though we are getting graduate, the skill is another major was the challenge for these people. To get to marketability and employability was the second challenge. That is a different part of the story. But the major thing is skill labor shortage. And second one is environmental compliances. So the foundries having a very the foundries are tend to be polluted. So here we will be having latest advantages that we are proposing to use CNGs as well as biomass instead of this existing conventional thing. So in order to avoid this pollution, this thing. So there is again pollution complaints was there. So even majority of the industries nowadays they are using these solar powered things in order to avoid all this. So in order to make them pollution free. So the third one is cost pressures. So since the competition fluctuations, as you know, tariffs, the continuously from the US and China tariffs is just squeezing the market, which is becoming a very highly volatile market. Nowadays, the foundry market was become very highly volatile since this all the US tariffs and Chinese tariffs, UK tariffs, so trade-free agreements. So all these exports and imports are getting calculated day by day. So these cost pressures are there, and the cost is become highly volatile. We cannot predict how the market will be tomorrow, how the rate will be in the next week. So this week we'll be having good rate, but we don't know next week what happens. What is the rate of the raw material, or what is the rate of the product? So and also we'll be having quality and speed demands. The OEMs, even though the OEMs, the original equipment manufacturers, so they will be having demand. So they will be having higher demand, but in the market. So the Indian foundries are facing the raw material shortage problems nowadays, and also the supply chain problems. So these are the major challenges that are facing by Indian foundries today. The major one is the shortage of raw materials. The second one is the shortage of skilled labor, and the third one is strict environmental compliances, and the fourth one is due to tariff, the cost pressures. So these are all the challenges faced by Indian foundries. So let me show one of the major foundry, that is Munjal Castings, which is Punjab based, Ludhiana based, and normally it used to supply its components to Hero Motocorp, Suzuki, and global automotive companies. So this company previously, when it is comparatively before automated and after automated, so this company could able to boost 50 to 70% of its effectiveness after that could able to boost its productivity, and it could able to reduce its defects by 50 to rejections by 50 to 70%. So, and now previously it will be having very less production capacity. After the automation, it could able to make 250 to 270 components daily per mission, and almost daily 2 lakhs castings it is supplying. So you just imagine whenever if 50% of its rejections get reduced, means almost 1 lakh castings getting more than 1 lakh castings getting accepted. So it's a huge breakthrough for this Munjal Castings. And another thing is the Bharat Forge company. So this is also a very good company which is making the components for defense and automotive components and aerospace components manufactured by this Bharat Forge. So this also made 15% improvement after this particular automation. Previously, it will be having a challenge that since it is a very big company, it is operating at various locations and handling at different locations, and making the components, since it is only having machining at one location, casting in another location, so breakdown at one particular point also will impact the entire its business. But after that, also of complete automation, they could able to manage the things very easily. And more than 2,500 engineers are trained with this industry 4.0 technologies, all this robotic process. So they could able to now make fully automated, they can run fully automated industries now. And even Swaraj tractors, the production in the Swaraj tractors also, after implementing the automation and robotics, so they could able to increase productivity by 67%. So these automation benefits as with your productivity increased. So even 3 hours we discussed, only these points will come across. The one is increasing of productivity, like the enhancement of quality, cost optimization, worker safety, and production flexibility. We'll see how these are the trends in the automation. These trends are required in this 2025 year. So when you wanted to venture into automation, so these are the minimum things that we need to know. So for this, let me show a small video.
If you work in industrial automation, staying updated isn't just important, it's essential. Technology is evolving faster than ever, and the skills that were in demand yesterday might not be enough tomorrow. From AI-powered PLCs to fully autonomous factories, 2025 is bringing massive changes. So if you want to stay relevant, boost your career, and be ahead of the competition, you need to know these trends. In this video, I'll break down the top 10 automation trends of 2025 so you can stay ahead, future-proof your skills, and grow in your career. Let's dive in. One of the biggest game changers in automation is artificial intelligence and predictive maintenance. We've all seen this happen. Production suddenly stops because a machine fails, leading to hours of troubleshooting and huge financial losses. But what if your machines could tell you they were going to fail before they actually did? That's exactly what AI-powered predictive maintenance is doing in 2025. Sensors installed on machines collect data in real time, AI analyzes patterns, and you get an early warning before a breakdown occurs. This means fewer surprises, less downtime, and huge cost savings for industries. Companies using this technology have already reduced unplanned shutdowns by up to 30%, saving millions. If you're working with SCADA or DCS, expect to see more AI-driven monitoring and fault detection in your systems. Moving forward, another trend that's transforming industrial automation is edge computing, which is making PLCs and industrial networks faster and smarter. Traditionally, industrial systems send data to cloud servers for processing, but this can create delays. In 2025, edge computing is bringing the processing power closer to the machines, right inside your PLCs and controllers. This means real-time responses, faster decision-making, and lower network congestion. For engineers working with DCS, SCADA, and automation systems, this means faster troubleshooting, better data security, and more efficient industrial processes. Another major shift happening right now is the rise of digital twins and IIoT, which are making factories smarter and more connected than ever before. Imagine having a virtual copy of your factory that allows you to test, optimize, and predict failures without touching the actual machines. That's what digital twins do. They replicate entire industrial processes in a simulated environment so that engineers can detect problems and optimize efficiency before making real-world changes. Combined with Industrial Internet of Things, IIoT, every sensor, PLC, and SCADA system is connected, providing real-time performance insights. Companies using this technology are already seeing better production efficiency and fewer costly errors. Now let's talk about how robots are changing the way humans work in factories. In 2025, robots aren't replacing human workers. They're working alongside them. Collaborative robots, or cobots, are designed to assist with repetitive or physically demanding tasks, while human workers handle more complex decisions and programming. For example, Tesla factories use cobots to speed up production and reduce human errors. This means that engineers now need to focus more on PLC programming, robot integration, and automation control, rather than just manual operations. Speaking of connectivity, industrial automation is going wireless with the adoption of 5G technology. With 5G, industrial networks are becoming faster and more reliable. The low latency of 5G means that PLCs, SCADA systems, and IIoT devices can communicate in real time, even between different locations. This is especially useful for remote monitoring and control, allowing engineers to manage industrial plants from anywhere. While automation is making industries more efficient, cybersecurity threats are also increasing. With more automation and connectivity, industrial systems are also more vulnerable to cyber attacks. New cybersecurity standards like IEC 62443 and Zero Trust Security are becoming essential for protecting SCADA and industrial networks. If you work in automation, understanding secure PLC programming, network segmentation, and endpoint protection will be critical for the future. Cloud-based SCADA systems are also becoming more popular. More if you work in industrial automation.
Yeah, so as we discussed, the robots are much used in this die casting industries. So just want to show you another video about how the robots are used in die casting industry. That is just fast forward it. So this is a pre-finished component which is going to get casted in this industry. This is the layout. So this is how the robots are implemented as designed. So this is a initial simulation was made. A robotic arm taking the molten material and pouring it into a die. That is simulated, but actually the same which has taken place. Here we'll be having 4 die casting machines which are revolving, adjusting their position according to the cycle time. Here the robotic arm itself is carrying the molten material. The person is adjusting the cycle time. Yeah. This is the robotic arm. As simulated similar way, the robotic arm is lifting the molten material to the from the furnace. This furnace we normally call as a holding furnace. The furnace which is used to hold the molten material according to the required temperature. So that furnace we call as a holding furnace. From the holding furnace, the molten material is transferring. No pouring. The uniform pouring. This is for one cycle. After that, this machine will get relocated. This ladle will get preheated. Why? Because of the transferring molten metal, right? So the ladle cannot be. The ladle also should have the same temperature of molten material. For that, ladle will get preheated. After pouring the molten material, the machine will be shifted in order to take the material. Since after pouring, it will take some time to get solidification. After solidification, the metal has to get removed, which is within the die. So, in order to avoid that delay, so in this particular application, we are using 4 different machines with the 2 robot pouring. That is a die insert is inserting there. Here, the robot will remove the casted part. In the simulation, the similar thing will get happen here. You can observe. So in similar manner, the die casted component is removed from the die. But the insert material was kept, and the runner riser excess material will get detached over there. That operation we call as a fettling operation. That is removing the excess material, the runner material, riser material, or casting or blows. Removing that material we call as a fettling operation. For that fettling operation is also happening here. So in this manner, the robots are used in die casting industries. So as I said, robotic fettling. So the robotic fettling was the removing of excess material we normally call as fettling operation. This is another challenging area. Why? Because of the castings are very integrate shape. So all the castings are not uniform. We'll be having various integrate shapes. We'll be having various inserts in the casting. So we need to remove all the excess material, workflow material. We need to grind the material. For that purpose, we'll be having a fettling operation where the manual intervention is much required and a tedious job and a very repeated and a fatigue job here in the foundry industries, especially this fettling operation. So here for the fettling, we need to here if you see pouring means if you take a suppose a company is having a brake lever order initially, and next time it will be having an brake shoe order. So, or it will be having some cover order. So, the even the whatever the component is different, the die will get vary, but for the robot, the work envelope, the action what it has to be done will be same. Maybe the cycle time will get vary based upon the component size, but the work envelope or the where the robotic arm has to move, that particular area is same. That it need to take the molten material from the furnace and it has to get poured into the die. So this is the same, but the die shape will be vary based upon the component to component. But when it comes to the fettling operation, when the component will get changed, so when the component will get changed, so here we the fettling, the material removal requirement will get vary. The overflow will vary, the shape will vary, the grinding position will vary. So here it is always R&D is required for every component here for this fettling operation. So this is where another critical area we could able to work. The AI is much required here. So which area, so suppose with the change of the component, how this existing setup could able to adjust for this new component for the fettling operation. This is where another area we could able to focus in the foundry industry. So the real-time fettling operation is required in modern foundry operation for especially for precision fettling operation. Even though nowadays we are using robots for the fettling operation, there will be 80% of the success rate and 20% manual intervention is required here. After the fettling, robotic fettling also for the manual inspection, or the few places where the machines cannot do the work most accurately that humans could be able to do. So in such areas that are more than 20% places, the humans are required for this fettling operations. So here what happens is with the human fettling operation, if we employ humans in the fettling operations, we could able to do fettling after the metal will get completely cooling only. So the heat condition we cannot operate. And the second one is when we are doing fettling or filing or grinding operation, there will be a lot of dust and toxic fumes will get involved and noise will be there. So humans will get affected over there. And here normally what happens, sir, when we are looking this fettling operation, no, so the labor shortage is more and the workforce crisis will be more here. That is, suppose we require 20 people for the fettling operation, even though we apply 20 people, every time there will be 3 to 4 people shortage will be there in any industry. They will be having some many leaves or other things. So they will be having some other extracurricular activity, some health issues. So there will be laser shortage, workforce crisis will be there in industries, and it is a physical strain will be there, more fatigue will be there, and more repeated work they have to do. So suppose they are employed to do filing operation on one particular location, they need to pick every component and place in the particular day or particular position. So and they need to do the repeatedly that filing operation day in and day out. From morning to evening, the same operation they have to do. So and there will be a safety concern also will be there, and there will be quality issues also there. Since humans are operating, there will be since when then they want to remove 1.5 mm material, sometimes they remove 3 mm material. So, and again the entire casting will get rejected with that. So sometimes they will do filing only 1 mm material will get removed, even though the material will get rejected. So so like this, there will be the manual fettling. There is a huge what we call rejection rate will be there, and more fatigue is involved here. The robotic fettling, what happens here with the robotic, with help of robotic fettling, the advanced sensing, the robots are equipped with sophisticated sensors and vision systems, enable precision material removal and real-time adjustment that they could able to do. And there is a much research need to be done in this area. AI need to get involved here. So in some areas where we need to work more forcefully, where the cutting precision is required, where the tolerances are very great. In that particular areas, the AI need to get involved here in the robotic fettling area. So the researchers or the professors who are much interested to work with the real-time environment, real-time industries in the industrial collaborations, they could able to plan this robotic fettling area. They can plan to work in this robotic fettling area. So here, what a continuous operation. The fettling, since if suppose as a sure Manjal Shiva is itself is delivering more than 2 lakh components a day, so that 2 lakh components will get fettled every day. So for 2 lakh components, so for each component at least some 10 to 15 areas we need to get grind and remove the material. That is 2 lakhs into 15, almost 30 lakhs. 30 lakhs areas, 30 lakhs machines are required, 30 lakhs quality instructions are required for each and every day. So this is if you see in a small industry, if you see in the component level, it may be a smaller task, but when you go to the bigger industries, it is again very big task, where the tolerances and the repeatabilities and fatigue is much involved over there. So, and we will be having a heavy duty compatibility. The missions which are working here should have more heavy duty compatibility is required, and worker protection is also much required here. So integrating into robotic fettling line with the material handling automation as again with this robotic fettling, we could able to enhance the productivity and cost will get saved, and the environmental benefits will be there, and we can make smart manufacturing. So, Grindmaster series is another company which is under Richmond Robot Center, and so these are the companies which are mainly focusing now on robotic fettling, and in the sectors of aerospace and automotive, fettling is much required. The barriers here, challenges was the fettling is a small task. Again, if you see in the individual level, the removing of 1.5 mm material in different locations is one of the job that need to be done. So for that particular task, implementing again, if you use the robots, the initial investment cost is much higher. Even if you could able to employ a daily labor whose salary will be 600 or 800 rupees per day, even per month it is 16 to 18,000 labor could able to do this task. But if you go with the robotics, some 16 crores is required for this complete process. So again, it is a high upfront initial investment is required for this robotic fettling. So here the process limitations will be there. So even though as I said previously, 80% of the material can be able to remove through this robots automation, of 20% again still human intervention is required with this robotic fettling. And the flexibility, since diversifying the casting geometry and size, material type, so you'll be having different shapes, integrate shapes. Where for that integrate shapes, robotic fettling is again a typical and tedious task. For every component, we need to do R&D to set up this line. So these are the challenges that we have in the industry now. The human factors, suppose if you go with the humans, so for this normally skilled operator is not required. Only if you show the work, you take the file and remove this area for 1.5 mm. This is your day in day out job. So that no need of any skilled for this one. And so workforce resistance is one of the major problem here. That is getting the repeated workforce is one of the problem, and training requirement is also another problem here. So if you go with the robots, the future will be safer, smarter, and more efficient for this fettling. So finally, the conclusion line, so I could be able to say that the future is smart, connected, and automated. So it's time to act. The Indian foundries are now investing in automation. The entrepreneurs and researchers, the young engineers could be able to focus on this area. So where to convert existing industries to automation, or for supplying the automated components, the automated solutions to the existing as well as new industries will be the good area. So this is what I wanted to present in front of you today. So thank you very much for providing this opportunity. And first of all, sorry, after almost after 2 years, today I'm presenting a lecture. I'm out of college or out of in this area for past 2 years. I don't know how far I could able to make a justification today. So, and moreover, thank you, Guru Mahesh, for providing this opportunity, and as well as SV College of Engineering staff and team. And if you have anybody have any queries, let's have a discussion for a couple of minutes on this. If I could able to address that, I could able to address one.
Hello, good evening, sir. Myself, Dr. V.L. Krishnan. Nice presentation, sir. It was very fantastic presentation, actually. You showcased the entire process and then showcase so many real life industrial examples. It was nice. Sir, my question is that what type of software is being used for this modeling, digital twin sort of things, like aluminum process casting or whatever, what in industry?
Yes, sir. We have many advanced softwares nowadays are available in the market. So the FlowChem was one of the thing which is normally we use for simulations, for the flow simulations. So apart from that, we will be having many advanced softwares nowadays evolving, sir. The FlowSim and FlowChem are the few softwares that normally we use for simulation. And thank you very much for your feedback, sir.
Apart from this FlowChem, what you are saying is related to casting.
Yeah.
For like process modeling, like that entire process cycle time calculating and all those things for that modeling and simulation. What type of is basically modeling and simulation of robotic systems, I'm asking.
So I'm not in that area, sir. I'll let you know.
Okay, sir. Okay.
Dear participants, any questions? So, sir, if there is no questions, then can we conclude this session today? Dear participants, any doubts? Please feel to ask. Acha, sir, shall we close the sessions?
Yes,
with remarks? Balaji, sir.
Yes, sir. Guru Mahesh, sir. Yes, sir. Sir, Guru Mahesh, sir.
Sir, tell me, sir.
Can I provide the vote of thanks, sir?
Okay, sir.
Yes, sir. So thank you, sir. Thank you for your valuable time, sir. So on behalf of SCC Tirupati, I extend my heartfelt gratitude to our distinguished speaker, Dr. Harshvardhan, for sharing his valuable insights on case studies and success stories of industrial robotics. His talk was enriching, thought-provoking, and gave us a clear understanding of how the entire process takes place in the industries. Sir, your vast experience from patents and publications to consultancy and leadership added great value today for the today's session. We truly appreciate the time and effort you dedicated despite your busy schedule. I would also like to thank our respected management, coordinators, Gurumaya sir, and Dr. G. Gurumaya sir, and Dr. Rajesh sir, and faculty members, and all the participants for making this event a success. So thank you, sir. Thank you all once again. Have a good night, sir.
So thank you all. Good night.
Acha, sir, thank you, sir.
Thank you, sir. Thank you.
Sir, dear participants, the feedback link is posted in Google chat box. Kindly give your feedback by using that link. And tomorrow session will start at 2:30 p.m. sharp. So the speaker details will going to share in WhatsApp group. The test will conducted at evening session. So kindly all the participants attend the test and get 80% marks, then only you are eligible for getting a certificate. So the link is open up to 10:30. Kindly give your feedback. Tomorrow the session will start at 2:30. And once we receive the PPTs for all the participants, we can share to you. And that entire session's YouTube live links will be shared in the group. The recorded sessions already recorded and will show put in YouTube. YouTube links also will going to share in YouTube, sorry, WhatsApp channel. And after receiving the PPTs, we will share. We received one PPT from the speaker and already we shared with you. Some Govind sir has already posted, sir, request PPTs regarding PPTs. Once we get the PPTs from the resource person, we'll share to you, sir. The recorded sessions will be available in YouTube. We'll share the links. Already Sarah shared in the WhatsApp. Just to go through that, sir. The test timing at evening, sir, after 6:30. So the session starts at 2:30. First session is preparation of academic curriculum for robotics, introducing lab and subject to the BTech and PG peoples. Second session, proposal writing. Third section is purely that robotic simulation. Dear participants, kindly fill the feedback form. It is already posted in chat box. Sir Rajesh sir.
Sir.
Shall we close the call, sir?
Yes, sir. Yes, sir. We can close.
Sir. Hello, sir.
Tell me, ma'am. Surpa ma'am, tell me, ma'am.
Sir, can you repeat tomorrow for me?
So tomorrow session start at 2:30. Tomorrow session will start at 2:30, ma'am. End at 6:30. The test time is 6:30 to 7. So after filling the feedback, form in ATAL portal, and after that only you will get the certificates. You must and should fill the feedback form in ATAL portal tomorrow.
Okay, sir. Thank you so much. Yeah, yes.
So shall we close the call, sir?
Yes, sir. We can close. I think there are no doubts.
Okay. So good night, dear participants. Thank you for patient listening.
Thank you, sir.
Thank you.